Hi, welcome to the first in the series of the Out of Band Back channel, which is basically going to be probably just rants, but there might be some occasional interesting background, incidental side information in it. The first one is a rant. It's why most sample code you'll find for ESP 8266 is rubbish. But first, please subscribe to the channel, click on the like button, click the bell icon to get notified, and support me on Patreon if you can. There's a link in the description below. Gonna have to apologise for any noise in the background. You can hear that's rain on the window. It might make the video more interesting. So what I'm looking at is why most example code you'll find on the net is rubbish. So using as an example to start with, we'll look at the kind of standard method of starting a Wi-Fi sketch. And you'll see this in almost every sketch you find. So you might be fooled into thinking, therefore, that this must be the best way to do it, or the way to do it, or the recommended way to do it. But in actual fact, as I am about to show you, it's about the worst possible way that you can do it. So why is that? Well, first of all, it's synchronous and blocking, and there's a little subscript there which I'll talk about in a second, neither of which are good in a real-time environment. And a real-time environment is the one that we bought the ESP8266 to use, isn't it? To monitor sensors and alarms and lights and things that happen in real time. It's a Wi-Fi device. Wi-Fi happens in real time. So deliberately choosing code that doesn't match the kind of temporal model of what it's trying to monitor is inherently a bad idea. However, I accept that that is a bit of a purist argument. But moving on, it doesn't automatically reconnect another subscript to Wi-Fi if the signal's lost. So if you lose your connection to the Wi-Fi, the only way back is to physically reboot the machine, which is not really much use in the real world, is it? But finally, it's slower than other much better methods that solve subscripts 1 and 2. Let's get those out of the way before we continue, because neither of them are strictly true. It's not blocking in the sense that it is going to cause a watchdog timer reset, because the delay that you see in there specifically coded so that you can get a timed delay without locking out the Wi-Fi and causing a reboot. However, you can't do anything else. You cannot run any of your hardware and check all your sensors while you're waiting for that Wi-Fi to connect. So by definition, it's going to take longer to come up than something that doesn't wait for the Wi-Fi to connect. So if you're trying to run real-world hardware in a critical environment where you want it to be operating the hardware, no matter whether there's a connection or not, then that code is utterly useless to you. So the second thing is it does automatically reconnect. By default, the way that the ESP8266 comes delivered is that it will remember the credentials of the last good Wi-Fi it connected to and automatically reconnect to them when it next powers up. And that is without you writing a single line of code. So if you try a little experiment, get a connection, then edit the sketch, remove everything from it apart from an empty setup and an empty loop, so you've got no code in there whatsoever, and then run it again it will connect to the Wi-Fi, the last SSID you used. Right. So what's the problem with me saying it doesn't automatically reconnect then? Under the covers it does, but your code can't tell that that's happened. So if your loop is doing something like regularly trying to access a remote website, that code is just not going to work. It's going to break. And in the best case scenario, it breaks in a nice way and just doesn't do what it was meant to do, nor ever will until you reboot your machine. But there are situations where trying to do things that are unavailable repeatedly in a loop without error checking or taking account of it or backing off the rate at which you do it will actually crash the machine. Again, not very good. So why then is it seen in 95% of examples? Because it's easy and obvious to beginners. And most of the examples that you get are for beginners to show people how to use stuff. So that sounds like a good idea. It avoids complex concepts that are involved in not doing it that simple way, which means event-driven, non-blocking code. Now, for most people, certainly all beginners, that may as well be Greek. They won't understand what it means, and when you do start to understand what it means, you think, oh goodness me, what have I got myself into? Because it is not a simple concept. Even experienced programmers have problems with event-driven and non-blocking code. So if you can avoid that completely, that's a bonus. So again, that's a really good reason for it being that way. And it also has to avoid putting in the code that I've been talking about that ought to be there to manage the reconnection. So you get a clean and simple sketch that shows one simple function of the example. And that's where the problem lies, is because this is demo code. It is there to show a simple example. It is not real world code. It's not meant to be used in the real world, and it does not work properly or well in the real world. So actually we need to change our original stance then, because really most ESP examples code is great for simple one concept demos for all these reasons. But when you turn that around and try and talk about real world apps, all of the benefits become serious negatives. And let's look in more detail at that. So we'll reword our phrase then. It's rubbish when used in real world applications. So what's the better way of doing it then that I keep talking about? Well, the better method is, first of all, you need to restructure your whole sketch to be asynchronous. That in itself is a world of explanation. I'm not going to cover what that means here. But your loop should do nothing. There should be no code in the loop at all. And you should monitor Wi-Fi events for got IP, which means basically you're connected, and lost IP, which means, oh, it's disappeared. So you need the whole code to be event-driven. When you get the got IP, oh, let's do it backwards. When you lose the IP, you've got to stop doing things that are connected to the net, because they're not going to work. So why bother? And if they're not going to work, and why bother, and they're using resources, then you need to deallocate those resources. Because otherwise, if, when you get the got IP, you allocate resources blindly, you're going to start running out of resources, cause a heap exhaustion, and crash the machine. So once you get the got IP, saying you've got a connection, or a reconnection, and that's the point, this will automatically then pick up where it went off without you needing to know or having to physically touch the device to reboot it. This will just work. So you take all your code out of the loop and you put it where it can run when you know you've got a Wi-Fi connection. Now that is why the previous example is the one that's always seen in examples, because what I'm showing you there is a new concept and a new way of thinking, lots more code and quite complicated. But let's look at this. These are the actual screenshots of the tests I ran. I ran 10 times. I just hit the hardware reset button and measured how much time it took from that to the start of getting connected to the Wi-Fi. So on the left you've got the standard method, and on the right you've got the H4 plugins. Now the summary of those is this: that the average startup time for the classic method is 2.1 seconds, whereas the average startup time for H4 plugins is 0.2 of a second, 0.3 nearly. Either way, it's 8 times faster doing it the way that I've described rather than the classic way that everybody uses, so it must be okay. Really? It's got a lot of problems with it. It doesn't reconnect, and it's 8 times slower. In what world is there anything okay about that? In the worst case scenario, 4 seconds to connect, 0.3 of a second with H4 plugins, 13 times faster. So I think you'll give me this, and if you don't, I'm taking it anyway. I'd say, on average, it's a nice round figure headline. It's 10 times faster not doing it the way that 95% of people do. And if that doesn't rock your boat and change your world, then nothing will. What's the upshot of all this? The upshot is use H4 plugins instead of the bog standard rubbish example code, which is 10 times slower.